Great, thank you. I think I've got a mic. So. Great, thank you. Just a bit about myself and the company I work for. So I work for Seldon. We were based in the Barclays FinTech Accelerator. We participated in the Barclays Techstars Accelerator a couple of years ago. And we're quite a generalist platform, but we're really focusing on machine learning deployment. We've got two products. So we've got open source machine learning, which I'm going to talk about today, is one of the products we're involved in, and we're working on a deployed product which is much higher level, so enterprise machine learning deployment, graphical interface and stuff. We do end-to-end machine learning projects. So we have worked in several projects, so not just the deployment, but also on the actual data science as well. That really gives us experience in certain verticals, because we're working in fintechs, working in different banks. So we do FX currency prediction. We've worked with a North American bank there, so obviously we've got quite low latency, quite stringent requirements on that. And we're doing another project in churn prediction, so completely different. It's like not low latency, but different challenges there. And we also do sort of content recommendation with HP. So quite a varied set of products, but we're really focusing on deployment. And these projects really give us more experience, really, of what, at the sort of battle face of what is required by our customers. Oh, yeah, and we also do the TensorFlow meetup in London, which is the largest UK TensorFlow meetup. It gets about 100 people every month or so. And so if you guys are anybody interested in learning more about TensorFlow, we have a range of talks, quite advanced, quite beginner. And so, yeah, look out for that. So what I want to talk about today is really a couple of things. Try to convince you machine learning on Kubernetes is a good thing. And I'll explain what Kubernetes is if you don't know what it is. And discuss two projects. One is Kubeflow, which is a project that's come out of Google. It was launched at KubeCon in December of last year, open source. And our own open source project, Seldon Core, which was released in January. And they're both in this ecosystem of machine learning on top of Kubernetes. But sort of the overall sort of arching thing that needs to be at the back of your mind is one thing we're trying to solve is get different personas to work together to get a successful data science project. So you obviously have your data scientist that's doing the analyzing the data, creating the predictive model. But then there's sometimes a tension between those and the DevOps that have to put it into production and manage that. They don't have the experience of the actual data science. And the other way around, the data scientists don't really want to work a lot with DevOps. You've got to get that tension there to work out successfully to get a good project. And then obviously you've got the people who have to do the approvals and are setting up the project, want to check whether you're actually getting the ROI on the project, et cetera. And so getting these three personas that to work well is like a real challenge. And that's also what we're trying to solve at a sort of a high level, basically, as in the work we're doing. So this is a slide from Kubeflow that I've taken, really just showing that to do a successful data science project has a lot of stages, a lot of things you've got to go through, and you really need to try and solve these in a consistent manner from the development into production, because if there's sort of disparities or gaps into how you're solving things, that's more likely to introduce bugs in what you're trying to do. So it's complex, and the projects we're trying to do is trying to make it easier for data scientists to actually make a successful data science project that's doing all these different steps, basically all the way through. So first, quick step about Kubernetes and why that would be a good thing. So just a quick introduction to Kubernetes for those in the room who don't know it. Basically, it's trying to solve the issue that if you're trying to create a Dockerized application, normally you have many different types of services that need to talk together via the network and need to have different hardware requirements, and you need to orchestrate all those. And that's really difficult to do at scale. So Kubernetes is a platform that's basically like a sort of compute platform that allows you to describe your deployments, and it manages it on scales from one machine up to several thousand nodes. And basically takes away the pain of building these complex services. And obviously machine learning is a complex service and needs to be run, and so building on top of Kubernetes is a great thing to do for machine learning. Then more sort of specifically some reasons why it's great. I mean, it's cloud neutral, so if you're choosing Kubernetes, you can run on any cloud or on-prem, and it's reasonably simple to then move between those different situations. Also has abstractions over the hardware you will need for machine learning, such as GPUs. So you can say these tasks require GPU, and it'll push it onto nodes that have GPU, et cetera. And then at the top left, there's some standard things that come as part of Kubernetes, which really need to be solved as part of any software project, but are also important for machine learning deployment and shouldn't be forgotten. So something like role-based authentication, so you can check that the application that's running can only do certain things with certain resources, so it's limited there. Health checks and scaling and quota management, so you can ensure that your particular machine learning deployments are not using too much quota. So all these are there, and therefore makes a great platform to therefore build machine learning on top of. And there's a lot of projects out there like Spark, Jupyter, which are running now on top of Kubernetes, and our project and Kubeflow are part of that sort of ecosystem. So coming back to this set of stages to solve machine learning, and just situating the two projects I'm going to talk about. So Seldon Core is really just focused on deployment. These last stages at the end, and perhaps, I suppose, logging as well. And Kubeflow, out of Google, is really trying to, in my opinion, to create like an ecosystem of machine learning. So trying to get best practice of, so data scientists can choose the different tools they want to use to solve these stages and to bring them in easily together to create your data science project. So I'm going to discuss a bit about Kubeflow. There's the reference if you want to look at it on GitHub. And here's a few more reasons they've given from Kubeflow for why they think machine learning on Kubernetes is important. First, you've got the abstraction, as I mentioned, over GPUs, and there's a lot of work on other types of hardware, like FPGAs in the future, so you can easily require these as part of your setup. It's easy to create abstractions on top of Kubernetes, and that's what Seldon Core and Kubeflow does in terms of describing high-level machine learning tasks that you want to run, and that's what we do to make it easier to actually deploy machine learning services. Scales, obviously, I've said that, and there's a lot of standard base images that are out there that allow you to build up these projects easily and connect them together. Also, it's really easy to create auto-scaling as well, so you can create auto-scaling based on certain metrics, which is obviously key for your deployment situations. And you can also, if you've got sort of constrained resources, set certain levels to get rid of tasks that have low priority and push that higher priority tasks in. And finally, it's got things like sort of data gravity. So obviously, some tasks need to run on nodes that have got local data that it needs to run, and that's also part of there. So you can use that as part of Kubernetes, and that's key to a lot of machine learning tasks. And you can specify, as I pretty much said, you can specify certain requirements for the hardware you need. So as things get deployed onto your cluster, they go to the appropriate nodes that have that hardware, such as GPUs, et cetera. So Kubeflow is basically built up as a set of components. This is what they have right now. So there's KSonnet, which is basically a deployment platform, a deployment tool for Kubernetes to allow you to deploy a certain set of packages. They have a Jupyter Hub built in, so that comes up as part of Kubeflow. And they have TensorFlow training built in, and they've created an abstraction of that, which I'll give a short example in a second. And they use Argo, which you may not have heard of, which is like a workflow tool to basically allow you to build up your pipeline of tasks, for training and deployment into a set of a graph of things that have to be done one after the other to actually put your training and deployment into practice, into your sort of continuous integration, et cetera. And deployment, they're using things like reverse proxy ambassador, which we're also using, which makes it easier to then tie in your apps to external applications that need to use your machine learning. And TensorFlow, yes, they've got that, and we're also part of that. So Seldon Core and TensorFlow are two deployment components you can choose as part of that. What they're doing into the future, they're looking at batch inference. Obviously, that's key for certain tasks. And they're trying to make it easy for users to get good metrics from the various tools they're using. And they're looking to integrate more different types of machine learning toolkits. So they've got TensorFlow serving in TensorFlow right now, and they're looking for MXNext, PyTorch, and things like Pachyderm as well in the near future. And a central dashboard, so it's really making it easy for data scientists to use all these things, basically. So what they've done in terms of Kubernetes is they've basically extended it. Kubernetes allows you to extend the sort of resources that you can describe. So they've extended it to allow you to describe a TensorFlow job. In this case, it's a distributed TensorFlow job here with 3 parts, a master worker and parameter server. So you can easily just add the images and the appropriate parts of that and say, OK, here's my description of what I want to run my TensorFlow job. You push that through the standard Kubernetes API, and then the operator that's running that they've written as part of Kubernetes will then interpret that description and launch your TensorFlow job and your training to run on that. So using Kubeflow, basically, at the moment, it's KSonnet, so it's still command line. So you basically choose the packages you want to install. So you say you want to install the core Kubeflow, you want to install TensorFlow job or TensorFlow serving, and put that in as part of the packages you want to deploy. But it's easy to just change those. So you say you don't want to use TensorFlow serving, you can just change that and use Seldon Core instead, and put that as part of your package setup. So yeah, as I say, TensorFlow serving is core to what they do, and I think TensorFlow serving is definitely a great project. It's really focused on low latency situations. Uses gRPC, which if you don't know, is like a binary protocol, so it's very good for low latency in terms of that. And they've optimized the gRPC implementation that comes in standard to optimize it for large data structures you might get in terms of prediction. And also done some great things in terms of predictive batching. If you've got different requests coming in on your machine learning predictions, you might say, well, I need to have a limit of, say, 100 milliseconds to get my responses back. And they basically join the requests together, understanding how long it normally takes for the request to be responded by the prediction. And then they send it out. So basically, it's batching to get maximum throughput through your GPUs. And they put a lot of work to do that. And it's really good. So it allows you to do basically single models. I think most people are using it just for TensorFlow models, but it is pluggable. You can write your own whatever models you want to run on TensorFlow serving. But mostly people use it for that use case. And for single model scenarios, it does have A/B testing, and you can switch between new versions of models and update that quite easily. So it's been around for a couple of years, and certainly for low latency situations where you want to have a single model you want to optimize, I think it's a great product. And that comes as part of Qflow, so the idea is obviously to make that easy to use for data scientists. So now I want to discuss the project I work on, Seldon Core. And as part of that, as I say, we're just focusing on deployment. So I just want to go through some of the deployment challenges that we think needs to be solved and some of the things we're working on in Seldon Core to solve that. So first, there's the core deployment aspects. So launching your deployment, scaling it up and down. A lot of this is helped by the fact you're using Kubernetes, so you get a lot of buy-in from that, basically. But then how do you want to update your deployment? And there's various ways to update your deployment, and I'll go through various situations that we're covering, like rolling, canary, and blue-green, et cetera. Then there's all aspects of optimization we want to work on. So obviously, you want to limit the amount of money you're spending on infrastructure for your machine learning deployment. So trying to optimize that so you're using your resources to the best of what's available in your cluster is key. And also optimizing your latency. So obviously, TensorFlow serving is great for that. And we want to also concentrate on that so you limit your latency. And this also helps your infrastructure costs. And that ties into throughput and then also optimizing models. So you've got different models. And so you might want to optimize between having multiple models running and optimize between which one is working best in real time and push traffic towards that. And we have various components to do that. Secondly, as part of what we do, definitely you want to expose your machine learning deployment to your business apps. And for that, REST and gRPC is probably the most common ways to do that. REST is obviously easiest to use. It's JSON, but it's probably slower. There's a lot of time wasted in serialization and deserialization. So gRPC is the other option. And in Seldon Core, we have both, basically. So it automatically exposes both of those for you. For what we're doing right now in Seldon Core, it's focused on synchronous, real-time, low latency. And in the future, we'll probably want to look at asynchronous. So you need to cover those aspects and see which is best for you. And then finally, there's a lot of things I think that needs to be solved in terms of management. So getting good auditing so you understand what is being changed as you roll up new updates to your machine learning predictions. And you put out new versions, basically. And also to get good data provenance. So how do you know for each prediction which was the data, which was the training model that was used as part of the model to create that prediction? That's key for any sort of business that needs to have good auditing, understanding what's happening in their flow. And secondly, you want to really tie it into CI/CD. So you want to, sure, it's machine learning, but you want to tie it into your standard Jenkins or Travis flows that you use in your organization, and so it can fit in really easily. And I'll discuss some techniques that come out, like GitOps, which came out as a concept that's been made popular by Weaveworks in the last few months. So secondly, some things that we're also concentrating on is we don't want, in terms of machine learning prediction, we don't want to limit what tools your data scientists use for training. So they can use any tools they want, TensorFlow, Scikit-learn, Spark, et cetera. And really, we just want to focus on the deployment side. So you allow people to easily use whichever tools they're using now, and then put the runtime inference part and deploy that. And as part of that runtime inference, we want to allow people to be very flexible in terms of the actual runtime graphs they deploy. So not just single models, but also A/B tests and multi-arm bandits to push traffic in real time, to to the best models, to separate out feature normalization and feature transformations, and to add in complex analytics into the runtime graph, like concept drift, so to determine whether your accuracy is dropping over time, so you can therefore change the model, and other things like bias detection, which is obviously key, and outlier detection. And some of these are in part of our open source right now, so you can use that to create reasonably complex graphs at runtime. So this is the top high-level view of the architecture. So obviously you've got your Kubernetes cluster, and you use the standard Kubernetes API, so that helps your DevOps because they don't have to change the practices they use. They can use the standard kubectl commands, or they can use other techniques they're using like Helm or Ksonic to push their machine learning deployments out there. So we have an operator that listens to a new resource type that's describing your runtime graph. It sees that resource type and then will manage and build up to the underlying infrastructure that comes as part of Kubernetes, so the deployments, the services, et cetera, all built up and managed for you and put it out there. And we have an extra component called an engine, which is going to manage that resource, that prediction, and so that request and a response flow through the graph. And as part of that, we then expose gRPC or REST out there, and we have our own API server that's running as part of the project, but we're also heavily looking into tools like Ambassador, which is a great sort of reverse proxy that basically allows you to plug in any authentication you want into your API, and it automatically spots just via annotations on your running resources and then exposes them automatically to your external apps. So that means you can put in any authentication you want. You can use OAuth, you could use Google IAP, et cetera, and you can choose what you want. So really what we're looking for is flexibility here, basically. So just to give them some examples of like complex graphs and what I'm talking about in that area. So obviously you have the simple situation where you just have a single model, and you have the request coming in from the left, the API, and response coming back out. But then maybe you want to make it more complex. Maybe you want to change that graph in real time with no downtime to an A/B test with your new model that you want to check. Or maybe you want to do something more complex and change that to like a multi-arm bandit. So a multi-arm bandit, for those who don't know, is basically it's looking at the feedback coming in and deciding which of your models is actually running best and pushing traffic to the model that's basically running best in real time. And it keeps monitoring the other model to see if things change and pushes traffic back to the other model if that's doing best. So we want to allow people to basically create these complex graphs and change them and push them out with no downtime. Maybe you want to separate out your feature transformations into a separate component and put that as a separate Docker container, because that would allow you to then maybe use that feature transformations between different projects in your teams and work on that separately. Add in outlier detection as a separate model, so that would be looking at the requests coming in, maybe adding some metadata as it comes back to say, okay, this request was an outlier, and you can feed that into what you're doing. And maybe doing more complex things that we've also worked on, like trying to explain the prediction. So maybe maybe your model is like a neural network that's very hard to explain to stakeholders outside, to sort of human beings, basically, as to what features it was using to actually get a good prediction. And you can use techniques that we've worked on to try and get a high-level understanding for a particular prediction. What were the features that actually were the most influential in giving the response for this prediction. So basically the idea is we want to allow people to easily iterate between complex graphs. Maybe in the end you go back to just having a single model, and that's fine. But to give people the flexibility to basically iterate between things is one of the things we're trying to do. So basically we have a set of core components, models, routers, combiners, transformers, which are abstract definitions with a microservice API. And basically then people can build up and use those components as they see fit. So obviously the key thing would be the model. That would be the standard thing that data scientists would work on. But you can build up multi-arm bandits, transformers into this just by conforming to the API, and then build it up and put everything together into the runtime graph. So this is a description of, this is an example rather of a Seldon deployment manifest. So it's standard Kubernetes JSON or YAML. And the components I'll show you now. So one part is the graph. So it's a graph definition where you define that graph I showed you in the previous slide, what you want to do. In this case, it's very simple. It's just a single item that you want to do. Then you have a standard piece of Kubernetes where you put the pod template spec, which is where you define all your standard Kubernetes stuff, like what was the image, what does it require? Does it require GPUs? Does it require like a volume, so NFS volume that it needs to attach to? How much memory and CPU? And that's pretty much standard Kubernetes that we just put in there. And so therefore, that can all be sorted out at runtime. Obviously, then you define the number of replicas, how many copies of this deployment graph do you want to put out there. And finally, we allow you to do multiple of prediction graphs. So this is cases where I'll show you where this is useful in a second. So not just one graph, but several in parallel that you want to have running. So scenarios where you'd want to have more complex graphs together running would be like a sort of canary deployment. So this, if you don't know, this is the case where you say you have your standard deployment running, so 10 replicas of your deployment, and you're very risk averse. You want to slowly see if the new model that you're going to put out there is going to cause any problems. So what you do is you create a separate deployment which is completely isolated from the other one, and maybe it's just running with one replica. So it's going to get a certain amount of the traffic, and then you can test out if that's going to fall over in production, exactly where it's going to cause any issues. And then finally, if you're happy with that, you can then do a rolling update. So just to clarify, so the standard thing would be to just do a rolling update. So if you had, say, 100 replicas of your graph, it would slowly drain down the 100 replicas of your previous graph and add in the new graph as it was going. So that's fine, but for people who want to be risk averse, maybe you want to do it in this way so you don't touch things and you just put out the graph that you want to run before that. And we can do that because we have that sort of set of predictions, as I showed in the previous graph, that you can define. Another common scenario that people talk about is blue-green deployments. So here you have your 10 replicas or 100 or whatever of your model running, and then basically you just create a separate set of infrastructure that's going to run your new model, also at the same size, and wait until you're happy that that's all running. Maybe it's loaded all the model parameters, et cetera. And then when you're finally happy that it's actually run, you then do the switch over. Obviously, the disadvantage to that is that you need twice the amount of infrastructure size in your cluster to manage that. But for some people, if you're very risk averse and you want to check things out, that's the best situation, and we handle that as well. A final one is some customers have asked us for this, where you have shadow deployments, which is where you want to just split the traffic as it comes in between two graphs, but not actually get the response from the second model. So you want to try it out in production, but you don't want to send the response back and just check whether it's working OK, but not on the same traffic that the real model is seeing, and just try to monitor it. And that's also covered. So the other thing I just want to go over quickly is we want to be completely agnostic in terms of how data scientists, what they use. And basically to put your runtime graph into Seldon Core, you just need to do two things. You just need to turn it into a Docker container and expose it to the microservice API. So it's not actually that difficult, but we want to make it really easy. So we're integrating things like Red Hat's OpenShift source to image, which basically allows you to use a tool which points to a source code repo on GitHub or locally. And using a build image that we supply, it packages everything up for you all in one command line. So this makes it very easy for data scientists to actually package up their runtime graph without many problems. I'll just give some very quick examples that are part of the code. You can look at this if you wish. So Python models is just one line using our Python builder image to package that. As a Python user, the runtime part, you just define a Python class with a predict method that takes a NumPy array. And then you can add a requirements.txt to add in all your dependencies. And you just define, OK, this is where the class is, and iris classifier. It needs a REST interface. And in this case, it's actually a model. And that's all we need. And then using S2I, we actually package it up and add all your requirements in, and that's it. Build the image, and you can push it to your repo and put it in, then put those images as part of your graph. And we do very similar things with R. So we've got a very similar case where you can just put the R model in, the actual dependencies, and do another S2I single line just with the R builder image and run that and create the image for you. And same for Java models. We're working on that right now, and that'll be out probably next week. You define a Spring class and do an interface and do the same thing, just one line. So really, there isn't much effort using these tools to allow your data scientists to take the runtime code and then create it into images, which then can be packaged and put into the graph. So really, as I said, the key steps are really three parts. You package your image for your runtime component. You describe your deployment in the graph, and in future we'll have a graphical interface that we're working on, which will probably be closed source, but part of the open source, obviously, command lines, you're using JSON and YAML, and then you deploy it using the standard Kubernetes API, and then so monitor it, and then go through that loop of updating your models and testing and getting further understandings of what's happening. So in terms of what's available for the external APIs that you tie your business apps into, there's two methods, predict and feedback. So predict is, as you would expect, to send in to get predictions. And to make it completely general, we allow you to send in either tensors, which are just a shaped set of floats, the same as TensorFlow serving. Or you can send ND arrays, which would be the case if you want to do sort of more natural language processing. We have multi-type information that you want to send in, and it's easier to use in sort of JSON situations where you're using the REST API. Or you can just send in any custom string or binary, but in those cases, you then have the limitation that some of the other modules, like outlier detection and stuff that are part of the open source at the moment, won't understand what they're seeing going through, so you can't use it in those scenarios. And then there's optional feedback API endpoint, and that's for use of things like multi-arm bandits, where you're sending in, okay, this request was correct, this response I got back was incorrect, and then you can use things like multi-arm bandits or concept drift to try to analyze what's going on with your machine learning. And so finally, all this has to be tied into standard CI/CD, and so we really like the idea of GitOps, which is basically taking the source control as the source of truth. So you'd have two source control repos, one for your deployment descriptions written in Kubernetes, declarative descriptions, and one for your code. And then basically the idea is you just fire off, as commits come into those repos, you fire off things completely from that, your CI pipeline and your continuous delivery using tools like Flux or KSonnet and stuff to tie it all together. And so it really creates a nice pipeline, and it allows you to also then do auditing and versioning very easily. So if things go wrong, as you're just using source control to fire everything off, you can just go back to the previous version and put that into production. And also for things like auditing, you can just, as it's all source control and it's all declarative, which is a great thing about Kubernetes, it's all declarative descriptions of what my infrastructure is going to, what I want my infrastructure to be. You can then just do simple checks in your source code between what has the data scientist changed. Okay, I see they've added more memory, et cetera to that, and you can easily tie that into your like approval process. So finally, just the roadmap. Where we want to concentrate on low latency. We're talking to people like NVIDIA to make sure we can tie into the things like TensorRT, which is like optimized to take your TensorFlow graph and optimize it, basically. So it runs with maximum throughput on like NVIDIA GPUs of different types. Predictive batching, that's a great thing in TensorFlow serving, and we want to put that into what we're doing, and and definitely data provenance, which probably isn't so much in there. We allow people to add arbitrary metadata to the requests and responses, but definitely want to do that because that's very key for some of our sort of fintech customers to work well. And handle distributed graphs. So some parts you might want to put on certain hardware of your graph and other parts on different hardware, and distribute that out in the best way. And handle things like service meshes like Istio to handle maybe parts of the graph in a good way. And finally, yes, as I say, we're going to Seldon Deploy, which will be a high-level product that allows you to do this in a more graphical way, because obviously the open source is very low level. So thank you.
Thank you. Any questions from the audience? Any comments? Something you would like to discuss? You might want to just stand up, speak loud.
Thank you very much for a nice talk. I have just a question on what method do you use for the explanations of your predictions? Integrated gradients or method shape values or stuff like that?
Yes, so in terms of how you would use it, and the explanations, it's really for complex, sort of non-linear models where it's very hard to get an interpretation of what features are actually being used as part of the result. And sometimes you want to take those models and say to stakeholders, human beings, okay, we think this was what the model was doing, and it was using these features. And so it gives confidence to the human beings that have to approve to put your machine learning out. So especially in sort of fintech use cases, they're very risk averse. So if they have a model that basically looks like a black box that they don't understand, it might be great in terms of accuracy, but if they can't give good explanations to what's going on to people higher level up, they're not going to get that approved. So that would be one use. But the restriction with these are normally quite slow to use. They normally, the standard techniques would be to actually sort of perturbate the feature values to see how the prediction is changing as you change certain features. And so therefore you need to run several thousand different feature requests through your model by taking the particular example you want to explain and slowly sort of perturbating different items to see which is changing the most. So yeah, I mean, there were interesting techniques. There's a lot of techniques like Lime is one that was very popular. It's come out a few years ago. And so yeah, there's a lot of work being done that for these reasons that I've said.
Any other question? I have one last one. You build an open source machine learning framework basically, and you deploy this with enterprises, right? So what is a personal lesson learned that you have implementing, helping enterprises, for example, in finance, using such an open source, machine learning framework?
I mean, I think it's really just to give them the confidence of making the choice. I mean, in terms of going from the closed source world to the open source world, just give them the confidence that they should look into give that flexibility to the data scientists, so the data scientists have the flexibility within the organization to choose what components. I think Kubeflow and ourselves are allowing that flexibility to give a much more open way of viewing data science. And also, they do like the fact that they can customize areas, because these are very flexible licenses. So they can take various areas and customize them for their own use cases as well.
Awesome. Then, thanks, Clive.
Okay, great.
Thanks for being here. Thank you.